Very cool. All right. Hello, everybody. Welcome to my presentation on an introduction to app deployment and how to deploy your Battlesnake and beyond. A couple double ands there, I just realized. Those of you who don't know me, I'm Matthew. Those of you who are sitting right here probably do. I'm the president of the CCSS. My main interests are in software development, system design, infrastructure. So I know like something about deploying apps or something like that. The general bit. I'm gonna be honest with you, I definitely know this stuff at a very high level as opposed to all like the fancy like what's actually going in terms of networking. But like for the most part, I've worked on some like fairly large systems and know some interesting stuff regarding deployment and stuff like that. So what is this presentation? So the intended kind of like outcome of this presentation, or what we're going to do is I was going to very briefly kind of walk through how to actually deploy the snake if you haven't already done that. I know a lot of people here are already kind of like testing their snake against stuff. We're going to very briefly kind of like walk through that documentation. And the main goal of this presentation is kind of break down like what's actually going on there, like what behind the scenes is actually happening, what a web server is versus some of the other parts, as well as talk about some other options for deploying things in the future, as Battlesnake normally recommends like Replit as its option. But I'm going to talk about some alternative things for if you're trying to deploy things on your own time or anything like that. At the very end, if I still have some time, I'm also going to talk a little bit about some like other like deployment patterns or stuff you might see in like the workplace and stuff like that. So yeah, let's get on going. So the first thing I had in here is like, yeah, let's deploy our Battlesnake. So if you haven't seen it before, the best place to do this honestly is to take a look at the quick start docs on the Battlesnake website. I can just pull this up real quick, and it'll give you kind of like the overview of what you need to do. Honestly, these docs are pretty good. Like, I don't know, I didn't have any trouble really getting this started once Addy kind of told me exactly where to click and stuff like that. Yeah, so I'm going to very briefly for the recording kind of go through the process of making a snake. So the first thing you kind of want to do is you want to pull out a starter template from the bunch here. If you've already logged in with your GitHub account, you'll very easily be able to kind of grab this template to get your snake going. So I'm going to create a new repository kind of using this Python template. And also for the people here, like there's no expectation that you're following this. This is very much just like if you haven't deployed the snake before, recording for people who are interested in like just seeing someone deploy a snake and stuff like that. But we will be, as the second half of this presentation, kind of breaking down like what is actually going on behind the scenes and like how the network requests are firing and stuff like that. So I'm just going to call this like test snake because I'm not going to put too much time into coming up with a fun name. When I was trying to do this before, I actually tried to make a private repo, and Battlesnake requires that you make your repo public now. So make sure when you are making your snake that you make it public, because you'll have to come all the way back here and change the settings, and that can be a little bit annoying at times, unfortunately. But yeah, I'm going to give it a second here, I guess, to generate that repository. In the meantime, I'm going to head back over to the docs here and see what it asks me to do next. I believe what the next step is, once you have this repository, you'll kind of notice in the README that you can actually deploy this onto Replit. So what Replit is, and I've got a slide for this that I'm just going to pull up here real quick, but Replit is like sort of an online integrated development environment. IDE, some of you might have heard that acronym before. Basically what Replit is giving you the ability to go onto a computer somewhere else in the world, in the cloud somewhere and stuff like that. And it gives you the ability to kind of pull in a terminal and execute code in that isolated environment that is optimized for development. So I've come here and I'm looking at how to get this this starter snake going here. And I think what I have to do is I have to go to this part here with my Replit, and I have to take the URL of my snake and kind of drop it in here. Accidentally lost my URL there, so I'm going to kind of head on back to my repositories and quickly grab the URL for my snake to get that Replit going. So come over here to starter snake. I believe my GitHub should already be in here, but oh, import from GitHub. Thank you, Addy. So I click on this import from GitHub thing. I put in the repo of my snake, and then it should just let me get this going here. So if I come over here, this is actually just booting up a Replit's kind of like setting us up a little instance here, setting us up a little development environment for us to play around in. And it should be, as soon as it gets started, about as simple as clicking run. I've run into a couple issues in the past with just clicking run where I had to like change the console window I was in, but we're going to see how that goes in a second. Obviously, the setup also varies based on which template you're using. I'm using the Python one because my presentation uses a lot of the Python libraries and dependencies as examples in the slides and stuff like that. But you could do, I don't know, set up any of the templates that Battlesnake provides. I'm going to click run here. I'm hoping this just kind of works and this exposes the web server like properly, works and exposes the URL we want and stuff like that. But if that doesn't work, then I'm pretty confident I know how to fix it. What's going on right now is it seems to just be installing all the dependencies it needs, and now it seems to have booted up our little thing. We're going to just verify that this actually works outside of Replit by putting it in our browser here, just to make sure it's actually getting outside of that, because I've run some issues where that didn't work in the past. But it seems that I'm able to access the initial sort of like get endpoint that's exposed by our Flask API here. And that should be indication that when we set up the webhook with Battlesnake, that this should work. So now that we have that set up, we've actually got like a very quickly, I'm going to go over this later, kind of explain what's actually going on here. But now that we actually have like a deployed copy of the snake, we're going to go on over to the Battlesnake page here that I think I've lost, or yes, this manage Battlesnakes tab. We're going to just create a new snake. I'm just going to name him Test Snake because I'm not too creative. And then I'm going to take the address of my API and kind of just throw it in the area here so that the webhook will properly register. You can also see here we actually have the option. I'm going to go over this in the slides in a little bit, but you also have the option to pick like where the deployment of the Battlesnake side is going. So you can either like pick like an AWS or a GCP thing. You probably want to pick the one closest to where you live and stuff like that. I guess I'm being prompted to go with Oregon, so I'll just kind of go with that for now. I'm going to click save, and this should just kind of set us up a snake. And if there was any errors or like something wasn't properly working, like it couldn't ping your snake properly, you get an error at this point. But it seems like we've pretty successfully gotten our snake to work. You can see that I just pinged it. So if we head on back over to Replit, you'll probably see, you'll see in the console that we have actually, I think, received like an info ping right here. Each of these info logs is just saying that someone requested the info about our snake, which is really cool. So if that just proves that we are actually getting some information there. So now that we have a snake set up, I'm going to go back over the slides and actually kind of break down what's actually happening. So, okay, so what is actually happening? I'm going to try and remember the exact order I have these slides in. I believe the next slide I'm opening, actually, I'm opening up like a case study on Replit. So the first thing I kind of want to talk about, because I think this is like the part that's like kind of ambiguous, is like kind of like what Replit is and like what it actually does and how it's deployed. I'm not going to go into a ton of information about this, but I did a lot of research on like what Replit is and how they actually do their own deployments and like how Replit works as a platform and stuff like that. I'm not going to be going into like crazy detail about that today, but I found a case study from Google Cloud basically describing like why Replit is on Google Cloud and all the unique services that Replit takes advantage of on GCP to like make their platform work. So if you're interested in any of like how Replit works from like how they, deploy and like how they like kind of partition, like spin up like containers and stuff and how they manage containers and how they manage all the different environments that you've got going on there. This is definitely like a good read. It'll give you a lot of information on that side, but this is definitely like, I don't even understand like half of what they're saying in this half the time. So like, I'm not going to pretend like I do. So I'm not going to talk about that too much in this presentation. I'm more just going to focus on like what we're really doing here with our Battlesnake. So what I really want to focus on is basically the idea of like, okay, like what's actually happening when you run the Python 3 main.py command, or like for some of you, it's probably just like Python, or again, this is very specific to Python, but however you run your Battlesnake, like what's actually going on. And the thing I want to really highlight here is when you're writing that command, you're actually kind of starting two things. So you're number one, actually, you're running both your web service and your web server. And the difference between those things is that a web service is basically an application that is essentially just accessed over a network. And a web server is essentially another program, usually something like that you're not editing at all, that essentially is responsible for delivering and letting you access that web service over HTTP. So in our case, because I'm using the default Python template, Flask is the thing that's allowing us to build our web service. So that all those like API endpoints, all that fancy stuff, that's like sort of the application that we've created. However, a web server is something kind of separate. You might be familiar. I'm hoping this next slide is the slide that has a bunch of options regarding other web servers, but it's essentially what allows us to expose and actually host and allow your request to access our application through HTTP. And these are just some other examples of popular web servers you might be familiar with. The one I'm probably the most familiar with is Nginx, because that's like a really popular like reverse proxy load balancing thing that people do. But obviously, like a lot of these other ones are extremely popular. I'm just less familiar with some of the other ones. At a very high level, this is kind of like what the diagram looks like when you break it down. So what's going on here is that Replit has essentially like given us access to a server somewhere in the world. I don't really know. I do know they host on GCP, but essentially what's going on is they're allowing us to access some server instance where they're allowing us to run our Python code there. Inside of that computer, we're running our web server, which is in this case, I don't know how to pronounce it exactly, but Unicorn, I believe, is the one that a lot of people were recommending me to use as a production web server with Flask for some reason. Why that one, I don't exactly know, but it's probably it was just what seemed to be recommended with Flask. But essentially, our web server is allowing us to then inside that kind of access our web service, which is the Python Flask code that we stole from the Battlesnake template. So that's a general overview of like kind of like what's going on there. Kind of already went over this slide. The next part I want to talk about is kind of the Battlesnake side of things. So when we were actually like setting up our Battlesnake or creating our Battlesnake, kind of want to talk about what's going on here. So what we're doing here is we're, number one, picking the region that our Battlesnake is going to be deployed in. So that's actually sort of just like there's kind of two elements to our application here. There's the in quotes, the deployment that Battlesnake is handling on their side, which is the deployment of the piece that's actually calling out to your application. And that's kind of what we're looking at here. And the other half that I was talking about is kind of the deployment of your piece, which is the actual like Replit environment that you're looking at. So when you're deploying the sort of Battlesnake piece, and when I say deploy, I sort of mean just like set up and save the Battlesnake. They're really handling the deployment in the background. But what you're doing here is you're providing this Battlesnake or Battlesnake with the URL of your API so that they know where to call to when they expect your snake to make moves. This mechanism is also known as like a webhook. It's called a webhook because similar to like, I guess how you'd like hook a fish, right? You're kind of providing it with the URL of your API so that it's already like attached on and it can send you events directly as opposed to needing to expect you to observe or pull for those events or something like that. So Battlesnake is pushing events to your service through this like webhook mechanism here. And then based on where you deploy it, it'll either end up on like GCP or AWS or something like that. So this is kind of like my like Google Slides view of the architecture I like threw together really quickly. But basically, there's kind of the two pieces. There's the piece you deployed in Replit, as I mentioned, as well as the piece that's provided by Battlesnake, which is either found inside of an AWS or a GCP instance. And what's happening is when you start a game and you run a game, Battlesnake or the piece that Battlesnake is kind of deploying for us will call out to your service and essentially ask you for how you think your snake should behave in those instances and stuff like that. The next piece I have here is kind of like, okay, so that's great. We were talking about Battlesnake, but like when you're deploying your own apps, you probably shouldn't deploy on or host things on Replit. And this is kind of why. So I looked into Replit and other options similar to it, like free tier app, like just general deployment resources that would provide something like this. And Replit has a couple things you should know about. Number one, Replit, if you don't access your API for long enough, they will sleep your application, which means like if you're not, I guess, using it within, I'd say, I don't remember what the exact time it was, but I remember it being very similar to Heroku. I'm going to talk about Heroku on another slide, but essentially what that means is like, let's say you're not using your app for more than like, I think it was a couple hours or something. What'll happen is Replit will basically shut down your app temporarily so that it's not taking up resources that they're paying for in that moment. It's again, for them, it's a cost thing. It's a free environment for them. So they want to make sure that they're not just paying for you to have something running all the time. But for bigger apps, right, that you might want to deploy, you definitely will want to have it run all the time. So that might be really important to you. The other thing I've sort of taken away from Replit is that Replit, again, is very optimized for like as a development environment. It's not something that is really made for a production use. And I'm going to be talking on a future slide about kind of like a development environment versus like a production environment type thing. And like some of the things you want to optimize for when you're using a development environment versus like a production environment. So a couple other things I mentioned like Heroku. For example, if we aren't going to deploy on Replit, where are we going to deploy? And some of those options, the one I personally like recommend to people as like a beginner option is DigitalOcean. All of these options, basically what they do will similarly let you kind of like purchase time on a computer somewhere else in the cloud. DigitalOcean's instance, I forget, like DigitalOcean droplets they're called, or essentially is what allows you to, you're basically renting a computer somewhere else in the world. Cost, I think like the lowest tier is like $5 a month or something. And you can do a lot of stuff with that. Like it's very, cheap, but again, like it's probably the most beginner friendly to get started with if you're trying to like deploy your app on somewhere. The option that people used to talk about a lot was this thing called Heroku. And what happened was Heroku used to have a free tier that let you kind of deploy like literally anything on it. It would have that sleep mechanism where if you didn't interact with your app for like 24 hours or something, it would have this like, you have to wait 20 seconds for your app to spin up type thing, but it was free, so no one really cared, and that was like a fun time. So today, Heroku no longer has this free tier. People are probably using it to like do some like Bitcoin mining funny stuff or something on there, and they want to take that free tier away. I don't know, but I can't really recommend Heroku anymore. If you're a beginner, I definitely recommend you check out DigitalOcean first. The next one I'm probably the most familiar with, and the one I'm going to talk about for a little bit is AWS. So AWS is like Amazon's web services. And the equivalent to like a DigitalOcean droplet, or basically like asking for an instance on AWS, is getting something called an EC2. EC2. The EC stands for Elastic Cloud. It's basically AWS's service for allowing you to rent out, again, a computer where you can host and run your stuff. EC2 though, and again, like a lot of the AWS products are very difficult to configure, especially for like beginners and stuff like that. So it's definitely something where I'd recommend possibly going with the second option I'm about to talk about with AWS, but because there's so many configuration options, AWS actually has another service called AWS Beanstalk. And what Beanstalk is it's actually a way of deploying an application to AWS without needing to know how to configure your EC2. So it completely, like, it makes development and deployment a lot simpler. It's essentially like a CLI tool that will allow you to deploy to AWS with like very little knowledge of how to set up an EC2. So if you are a beginner and you're trying to deploy something to AWS, I recommend maybe checking out the AWS Beanstalk service and seeing how that works. The other two big cloud providers in the world right now are GCP and Azure. So again, Azure and GCP also have equivalent things to the DigitalOcean Droplet EC2 type service. I don't know. I think AWS is probably like, they all have free tiers, but I think honestly of the three, usually people will tell you that AWS is like cheaper overall. A lot of people will tell you that GCP is a very expensive cloud provider. So I don't know. I'm pretty biased to AWS personally because that's what I've worked with, but that is up to you to determine how you want to go about that. So the next thing I want to talk about is how to like prepare an app for deployment. There's definitely some things you should consider when you're deploying an app. Some of those things, and if like I actually just put a screenshot here of like what the Flask documentation says, but if you actually look at Flask will actually tell you that it has a built-in like web server that's not suitable for production. And as I mentioned before, there's a lot of different web servers out there for like allowing people to access your app. Some of those web servers are definitely like more meant for production settings than others. And the other thing you have to know is that different web servers have like different advantages over other ones. So some web servers might allow for instead of like single requests, like you could have like concurrent requests going and like different properties like that and stuff like that. So when you are like preparing for deployment, you should definitely like make sure that you're not deploying on like the default development web server that comes with Flask, because that isn't great. But again, for your Battlesnakes, you don't have to worry about that. That's just something that if you are actually thinking of deploying like a real app, that you should consider. Something else I want to talk about is just the difference between like a development environment and a production environment. So usually when you're working in a development environment, there's a lot of stuff you like have going on. You usually have like application logs, you have warnings. In some cases, I've even worked on production apps where when you deploy it to production, you turn off all of the typing so that you don't have like weird type errors get thrown in production and stuff like that. So usually a lot of the overhead that creates will actually slow down your app. And you don't actually want that type checking or like some of these warnings or logs to go off when you're actually running your production app, because it can actually slow down the app itself. So when you're developing stuff locally, that's great. You're going to want to run a development setup, and that's great. But when you're in production, you're ideally going to want to run the like minified version of your code, or the code that like is the most optimal, so that when people are actually using it or interacting with it, you're going to get the best experience, or the users that are using your app will get the best experience. The other thing I want to mention that I see a lot of first-year students do is a lot of first-year students will, want to integrate with something, and they'll very often, need to get some kind of secret key or some kind of, API token of some kind, and they'll kind of put it directly in their code. I want to make it very clear that it's not a great idea to commit your secrets. You should definitely use this cool, handy thing called an environment variable. What an environment variable is basically if you have a .env file in your project and you have that going, you can reference .env, or different languages have different ways of doing it, but you can reference those environment variables in your code without directly putting your secret keys into your code. And this is also really great because let's say you are having, let's say you have like a production environment versus a development environment, right? You're probably gonna have different keys for different environments. Let's say, for example, you're working with like Stripe, which is like a payment provider. You probably don't want to actually charge your credit card when you're working in like a development setup. That wouldn't be too good. So you're probably gonna have a different like development style key for testing as opposed to in production when you're gonna actually want to deploy against like a real service like that. So the last part of this presentation is I want to talk a little bit about deployment at scale and some of the strategies that people actually use to deploy their apps at a scale that's like, not just a single process running on your computer. So what a lot of you are likely doing is you're probably turning your entire application off every time you want to make an update. This is really not a pattern, but like I Googled it and people call this the recreate deployment pattern. I don't know if this is like actually a thing, but we'll pretend it's a thing for the sake of this presentation. And what that means and the disadvantage of this is like basically you're turning your entire app off. And that's really bad because let's say you actually were hosting a thing that lots of people were using, your app is going to just straight up have downtime and your users aren't going to be able to use it when you turn it off, which is not very good. So all these other things I'm about to show you are like just ways to do this that are not like that. So downtime is bad. That's the general TLDR here, but that's great. The next pattern I guess I have on here, and this is like usually what I like, probably like the bare minimum pattern that I see a lot of people do is I guess what's called a rolling update pattern. So what this is basically you gradually roll out your version 2 and slowly replace version 1. This just means there's no downtime. This is like the bare minimum kind of like strategy for like just making sure you have something going. Again, it's that simple. These next couple patterns are a lot more complicated that I'm going to talk about here, but this first pattern I'm going to talk about is called the blue-green deployment pattern. It's very similar to the last pattern, but instead of rolling out slowly, what you do is you actually deploy the entire second update at the same time as the previous update. And once that first deploy has actually finished, then you point all your traffic at the second copy. And this, again, ensures zero downtime. But the main benefit you're getting here instead of with the previous strategy is you can actually instantly roll back a change because you actually have both environments running at the same time. So let's say you deploy a change and it breaks everything or something and you're losing millions of dollars or something like that, right? You can basically instantly point all your traffic back to the previous environment you were looking at as opposed to the one that's still going on. So this is, again, very safe and will enable, we'll give you that instant rollback thing. But the problem with this is, number one, it costs twice as much in hosting fees when you do have those two environments going at the same time. And the other problem is, let's say you have some requests go through your app, or let's say you have some traffic go through your app, and some of that traffic goes through the new version of your app, but in the previous version of your app, you don't know how to handle that equivalent traffic. How do you handle backwards compatibility? It becomes a very big problem. And at times, especially with let's say you did big database migration, or you did some kind of thing where the fields of the types that you're working with are different, then this is something that would definitely not work as well in the long run. The next pattern I have on here is known as the canary test pattern. This is really common in a lot of apps where what this basically is what you do is instead of deploying to all 100% of your users, what you do is you deploy your change to a small subset of your users. Maybe that's 5%, maybe that's 20%. And if you see that on those 20% of people that the app is breaking, then you can roll it back. You kind of use a small subset of people to verify if your change is actually going to break for everyone. And if you do see it's breaking, then you can roll it back. But if it's not breaking, then you're good to go. And what that means is let's say you're I don't know, some kind of a bank or an online shopping type thing. It means that at most you're only losing 20% of your potential money you could have been making or something like that. You're taking a bit of a risk, but at least, again, you're guaranteeing zero downtime. You have a faster rollback because again, you only deployed it to a very small subset of people. And you also have the ability to, again, monitor a lot more telemetry before you actually go out to verify that your update's not going to break anything. The disadvantage to this strategy is you definitely have a slower rollout, but that's also because you're choosing to have a slower rollout. You're choosing to basically only deploy to a small subset of people at a time. So you should expect that smaller rollout. The last pattern I actually have on here is something called the shadow test pattern. And what this is you can actually or what you're essentially doing with this pattern is in this pattern, what you do is you actually deploy, again, two versions of the app. And what you do is you send the production traffic through both copies to verify that the traffic is behaving, or like the app is behaving as you would with said production traffic, but you make sure that the second version of the environment is obfuscated enough from the first one that it doesn't actually affect your production data, or you're not actually breaking anything. Again, similar to one of the other, like the A/B testing pattern, like the main, I guess, like disadvantage of this is, again, like cost and operational overhead. You got to run 2 copies to make this work, which isn't great, but it is what it is. And yeah, that's basically everything I'm talking about in this presentation. Thanks for listening. Does anybody have any questions about anything I said, or are we all good? Awesome, cool, nice. Well, thank you all for listening. It was a fun presentation, and I'll pass it over to Addie, I guess.
Give it up for Matt.
Woo.